Good morning and welcome to the CADclass podcast. I'm Josh.
I'm Jake.
And each week we talk about all things 3D printing, making, and CAD, especially those questions related to the Discord server. And Jake, you've got some stuff to show off this week as well.
We've got a bunch of stuff, a bunch of stuff to show off.
This is the first, we talk about having the jitters in like the first 4 minutes of this podcast.
But mine just comes out as like I can't speak at all. It's ridiculous. Like every single time we do filming for like big long courses that we do, where it's like, oh, I'll be filming for like 6 hours today. All of the annoying hard work is in the first 20 minutes. That's the worst bit. And then afterwards, I'm cool as a cucumber.
Yeah,
I'm feeling a little under the weather today. I think I have a little bit of food poisoning. My fiance is currently upstairs in bed. Like this.
Oh no, I don't even think I knew that. We didn't even discuss this before the pod. This is news to me.
So I'm a little slow today.
So if you go running off set, I know what happened.
Yeah. So if you see me just go, yeah, that's why. Anyway, dude. This week's been super duper busy. What I've noticed on the Discord today, was just some really good discussions. Some really good kind of talking points that people just kind of going into. Not a load of people making stuff, which makes sense, but a bunch of discussion starting off points that were just really rad that I think we should kind of chat about. So one of the short that we had literally just posted half an hour ago was all about a little experiment that I saw on Reddit about 3 years ago. There was this guy who had this little low poly skull. I think it's the exact one that we have in our course. And just, he said, oh, I've submerged this in 70% alcohol for 20 minutes, took it out and let it dry overnight. And the entire thing, all the sharp corners were nice and rounded, all the layered faces were nice and smooth. And it was a bit of a, oh, wow, that looks great. So for a bit of a context for anyone who's new to 3D printing.
Don't dive too deep yet. I want you to get into it, but I want to say hello.
Oh, excuse me. Yeah, sorry. Go on.
Good morning, Joe Street, PC Van Vliet, Ogre, Maple Leaf Makers, Key to Like, Sam, and Cadence, and whoever else is in the chat but hasn't said hello yet. You should definitely say hello. Hop in.
Good morning.
So sorry, little housekeeping. Good morning. And just like every week before the pod, to see your names come in and to see the same people showing up week after week, it must mean that we're not too bad, right? We're not. We must not.
I wouldn't say that.
Blah, blah, blah. It's my turn actually to not be able to speak.
Yeah.
Here we go. It must mean that there's some. So yeah, that must be a little entertainment. Anyways, Jake, as you were, I just wanted to say hello to all the lovely folks.
So one of the parts, one of the big things of 3D printing is, I think, just progressively trying to get as close to a plastic injection molding visually and strength-wise as possible. Or for the past, oh god, how long has plastic injection molding been going on? Since the 50s, I think.
I'm gonna have to research it. Keep going.
That's a damn good question. It has been literally the peak. The idea is that you have a cavity mold, you inject molten plastic into it, cools down rapidly, mold separate, and out plops a plastic.
Okay, so
oh my god, out plops a plastic part. That's not just me. I want everyone on the stream to try and say that, because that's not easy.
So I have a trivia question on this note.
All right.
The trivia question is, in the chat, type what year you think plastic injection molding was invented. What year do you think it was invented? No cheating. I already cheated, so I can't obviously participate here.
I'm going to just give you a little tangent fun fact about plastic. So one of the very, very, very first types of like mass manufactured plastic was this thing called Bakelite. So if you imagine like an old school kind of 1960s phone where it's like big and red and it's got the clunk on it, it's a rotary phone. That kind of classic design. Those were called Bakelite phones, and the plastic that went into it, it is so unbelievably chaotic and dangerous. And you'll probably know more about this than me, Josh, but I think it's something like an ammonia hyper exothermic reaction, because it essentially explodes acidic plastic inside a mold, and it generates hundreds of degrees and it gives you like normally it would give you this kind of weird puffy, aerated, hard plastic. But in a mold, it gives you this lovely smooth thing. But it's like the very beginnings of any type of engineering or any type of product or material physics is always usually obscenely complicated, often dangerous, and then slowly becomes pretty normalized and safe. But I love learning about the beginnings of a tech.
Okay. So we've got some answers here. We've got Maple Leaf Maker says 62. PC Van Fleet says the 30s. Ogre says 52. Sam Coleman didn't give an answer, but did say he's got a 46 wiper motor with plastic.
Interesting. I would have said about 50, early 50s. I would have said
early
1951.
50s. Okay. Anybody else want to chime in? We'll give it another 30 seconds here for anybody else who wants to chime in. But
that's a good one. Yeah.
This is kind of fun. I'm with you. I love actually learning about the history, and specifically like why did somebody decide that the way to do this was to make a cavity, right? Like, how do you come up with this idea that like if you were to make a cavity and force under high temperature? I don't know. I love this stuff. Ridiculous. No clue at all. Joestre's afraid to even answer. I'm going to call him out. Afraid to even give a guess. Ooh.
That's fine.
Pressure's on.
There's no stupid questions, just stupid answers.
Yeah. Okay. You ready for this?
What's the answer?
Drum roll, please. Drum roll, please. 1872.
1872.
1872.
Whoa! Plastic injection molding. 1872.
Earlier than you think is what Cadence said. Yeah. So
wow,
I had no idea. I would not have guessed it was in the 1800s, and it was invented by when the first, and that was when the first molding machine was patented, by the way.
Yeah.
So plastic injection, it was invented in the 19th century by John and Isaiah Hyatt.
Interesting.
Yeah, and I'm wondering.
Wow,
let's see.
Crazy. That's really bizarre. I actually now want to learn a lot more about it now that it's so.
And it was two German scientists, Arthur and Theodore. Oh boy, here we go. I'm just going to say Arthur and Theodore created soluble forms.
It's a German name. We all know it's not. It's impossible.
Cellulose acetate, I believe. Cellulose acetate. Like plant wall, right?
Yeah.
So yeah, really cool. We were way off. Todd Nito says, yeah, I don't think I would have guessed 1872. And it looks like, I mean, if it was patented in 1872, clearly people had this idea before. So I guess it would have been derived. It would have been derived from this idea of mold making that we've had for, God, when do you think mold making was invented? Whoa.
I mean, God, that goes back to
mold making
ancient Greeks molding things in brass and copper,
Yeah.
Anyway, that was a very long tangent.
Anywho,
the idea to get it back
I like that.
Thank you. The idea with plastic injection molding, into cavity, inject some molten plastic, it cools. So the idea is that the plastic inside is one density. It is uniform. It is isotropic. It's got all of these qualities, but it essentially is equally strong in all dimensions, depending on the shape, obviously. And what you have with 3D printing is you have layer lines, which means it's not as smooth or as textured as the inside of a mold. And you also don't have equal strength. It's obviously more strong compressive than it is tensile. And it's got all of these different types of mechanical defects, really. And we are constantly trying to get stronger, quicker to print, and a better quality so that we can even approach plastic injection molding. That's the idea. And obviously with things like the Voron and stiff frames and more specifically detailed or more specifically engineered 3D printers for speed, for example, that gets us a little closer to plastic injection molding. That's great. Having different composites materials and having better infill and all this, significant material engineering. All right, that's getting us closer to strength. But the visuals has always been really funky, and it's always been kind of a balancing act with everyone. It's always been, all right, what are your slicer settings? What's your material? Is the 3D printer in an enclosure, or is it post-processed? Is it pre-processed? All of these things that go into it. And one of the things that has been really tricky is, okay, how do you get rid of those layer lines? And for a long time, on the early end of 3D printing with hobbyists, you had a lot of people doing ABS just because that was really the only filament you could get your hands on in bulk. ABS stands for, Josh?
Oh, is this the one that, let me see. I'll look it up. I actually don't know.
No. Do you know it? Because I can't pronounce. I know what it is, but I can't pronounce it. It's acrylate butane styrene. For anyone who doesn't know, Josh is a former chemist and he knows everything about chemistry.
No, I
do
not. I used to. I don't know much about it anymore.
Chemistry.
You know what's amazing to me is actually how little I remember over time. I really forget a lot. Acrylonitrile butadiene styrene.
There you go. Thank you very much.
Did not know.
And just as it gets into 3D printing, very tricky material to work with. What happens is it cools down very, very quickly. So if you're adding a layer on top of layer of something, as it's cooling down very quickly, it wants to shrink, and then you get layers peeling off of each other. So you get delamination. It's the exact same terminology as if you leave a piece of plywood outside in the rain, and as it dries, all those layers start to separate from each other. Same exact idea. And it has been tricky to deal with. So a lot of 3D printers that are made for ABS are built inside an enclosure. So a lot of them in the past have been called fridge printers. We used to have one at our old shop. You actually have to heat the nozzle, the bed, and the air around it. The air was about 60 degrees Celsius, which is like pushing into like 130 Fahrenheit.
Was it really?
Yeah. It was hot.
So the same, basically the same temperature as the bed.
No. It's a little bit lower than the bed, but it's the air. So anytime you open up the door, it's like walking into Death Valley or opening up the door to your oven. It's just like, oh, get it out again. Shut the door. It's an intense material. And one of the things that you can do with it that's way, way, way beneficial over PLA is that you can smooth it. You can melt it. You can actually put it in a container with a little bit of acetone vapors, and it essentially off-gases and it melts the outer surface. And as long as you put the 3D prints in there for just a short amount of time, the outer layer lines actually melt and it becomes lovely smooth. It actually looks like a plastic injection molded part if you do it well enough. And it has always been kind of the height visually. Oh, you've got an ABS acetone smooth part. That's beautiful. And then people try it with PLA and they very quickly realize it doesn't work. It just bleaches PLA. It just breaks it down molecularly. I believe it's the same. I could be wrong. I believe it's the same chemistry as if you try and bend plastic and it gets all white on the edges. Apparently, it's a similar thing going on with acetone, just chemically. It is really tricky to do. And so one of the other products that you can do is essentially a resin that you mix up and then you paint over the surface. And it makes it glossy and smooth, but it doesn't get rid of the layer lines, essentially. So on this post was, dunk it in 70% alcohol, take it out, let it dry overnight, and it's been on my bucket list of things to experiment with for years.
So at this point, I think it's unfair to call it a bucket list, right? Could you fit your ideas in a bucket? I don't think so. I think they probably need to. It's more like a. It's like, what do they fit in? This container's got to be bigger than a bucket now.
I don't know. I honestly, I think every single maker has a backlog, and it used to bum me out for a while, just like thinking like, oh God, what if I don't get to make everything I ever wanted? And then in Adam Savage's book, Everything's a Hammer, he has this really
everything's a hammer.
Anything's is it anything?
Every tool's a hammer.
Every tool's a hammer. Thank you.
Everything's a hammer.
And he has a quote in there, and it's everyone dies with a list, and it's a little depressing, but it's a little relieving.
I don't think nice. Everybody interesting does. There actually are people who just don't do things.
I don't know.
Can you believe?
I mean, that's not just making things. That's I want to read all these books from this author, or see all these films, or finally go to this place. Like, we all have lists, regardless of who you are. And I don't think there's a single person that is on their deathbed going, "Oh, checked it off. I tried.
Did it.
I tried this one last bit of sushi that I wanted to try. I'm done. All right." It's like, it doesn't happen, and that's fine. That's fine. Enough. That happens with everyone.
So you tried the experiment. Get you way off topic here.
Totally didn't work. Completely didn't work. I have this little print that I had just sitting on my desk for a while. It was a little Squidward's house model that I kind of love, and it printed it in marble PLA, which the flecks kind of hide the layer lines, but in real life you can see all the layers. It's pretty obvious. The post said 70% alcohol. I put it in 99% alcohol. So it should be even more melting quality. It said put it in there for 20 minutes. I put it in there for 25 minutes. So even more time. And I let it dry overnight. I think I let it dry for more than 24 hours. I think like 36. And it still had the exact same quality of layer lines. No difference. Myth busted. I don't know. I don't know where this guy got his picture from. I don't know if it was special white plastic or anything, but I got nowhere near close. I didn't get a smooth surface and I didn't get rounded corners either. So totally not. If you want a smooth surface, either invest in getting a slightly higher quality printer, invest in slightly high quality filament, or do what everyone else does and accept that 3D printing has certain defects and you just got to live with it. That's how it goes.
Or, you know, SLS, right?
Yeah, or
different,
SLS,
different style of 3D printing. I mean, I think when we talk about 3D printing, we get stuck in this idea that it's just extruded filament.
Yeah.
Yeah, it's just FDM. Although FDM is, I mean, yeah, for good reason.
FDM's right.
It's so useful.
Yeah. One thing that I do want to chat about that we did see in the post on Discord was people saying ABS or PETG, and I actually want to hear your thoughts.
Or ASA, right? So ASA is actually, yeah, that one I actually didn't know about ASA for a long time, but so you said the question was ABS, PLA. That was your original question.
ABS, PETG, or ASA.
So PETG has a slightly higher melting point. It will withstand temperatures at a slightly higher temperature. But I think, as it was pointed out, is it's actually not that much higher, right? Because you're still extruding
I think it's outside of a reasonable human level. Like, if you have a 3D print that's in an enclosed car in the direct sunlight, it's going to melt. And that's really the hottest kind of human environment we're going to be in, like, realistically. And so if you have a plastic that's melting point is just a little bit above that, then that's like, okay, yeah, that's good enough for most people.
So I want to say that ASA melts somewhere around 250 to 275. It's got a pretty high melting point. I don't know what is the melting point. So I guess the nozzle would tell us. The PLA melting point's like 150,
180.
It starts to get kind of liquidy around 150, 160. Obviously, you need to turn the hot end up higher because it's not going to get all the way to the middle of that. But I think it's like 150 to 160 on average for most PLAs.
So I think we can educate people a little bit. I know you know about glass temperature, but maybe the audience doesn't. So in material properties of plastic, you have this vague temperature called the glass temperature. No one really fully agrees on it exactly. It's just kind of a rough estimate. But it is when plastic doesn't melt, but it gets floppy. It starts to do phase transition. And
I wish, by the way, I wish that's how it were taught in classrooms.
Yeah,
like that description of it gets floppy is so good.
Yeah,
so
because we all kind of know what that's like.
That's right.
And it is so the idea with that is why it's so important. For PLA, it's about 60 degrees Celsius. The idea is that if you're going to put your filament into an oven to dehydrate it, you want to be below that glass temperature, because anything above it, the plastic will start, or if you imagine a spool of filament, it'll start to ooze into itself. And then instead of having a lovely spool of filament, you've got a kilogram of plastic. Good job. This all fused together.
So Derry's like, I was aware that that there's a melting point problem here. So with this, we're not picking on you at all, Derry. So we're just using this as a jumping off point for that discussion. I don't know what the ABS melting point is, and I don't know what the glass point is either.
I don't know either. So ABS, and
it's, by the way, it's usually
very popular.
Yeah, just from a science standpoint, melting points are given in ranges, not absolute values. So what will happen is especially when you're testing a melt, because what you do to test purity is sometimes you start with melting point. It'll tell you a lot about whether or not what you've made is pure, and it's obviously a crude test, and you need to do a lot more after that. But it will start to melt at a certain temperature, and it will fully melt at another temperature, and that gives you the range of the melting point. And you can learn a lot about, like, where did it start to melt, where did it end to melt, how big was the range, It'll tell you a lot about whether or not you have what you think you have, or if it's got impurities in it.
Interesting.
So I just remember
is that the difference? So I heard on QI years ago that there is a difference in temperature between when it goes from a solid to a liquid as when it goes from a liquid to a solid. Like people think 0 degrees is when water freezes, and that's not true. It's when ice melts. Like it's something like a 100th of a degree.
What's the point at which half of it will be liquid and half of it will be solid if it's completely pure, I believe. And now I'm like forgetting, so I might be stepping out of
that's fine.
once my chemistry roots here, but I believe that's what it means. It doesn't necessarily mean it's all. Yeah, but of course you're never going to get pure water. It's always going to have impurities in it.
And so pure water is kind of useless. It's poisonous to drink as well. Yeah. It actually pulls nutrients out of your body.
So ABS, I'm getting the melting temperature between 374 and 518 for ABS. And then
it's a very high temperature melting plastic.
What about the glass transition temperature?
I've never actually printed with ASA, so I don't have any
221 Fahrenheit experience. The glass transition temperature is 221 Fahrenheit.
Really? God, that's high. That's high. Really high.
Yeah, so that'll withstand insides of cars in Arizona for the most part.
Oh yeah, yeah. I imagine the car would start to melt before then.
That's ABS, and then PLA transition temperature is 60 C.
60 C, yeah.
170 to 180, and you'll often get these like. I think the easiest way to visualize it is a graph. So you can look at the graphs of these. So when I look these up, I that's where I tend to get the most information.
Yeah. But it's a really rad topic.
It is a rad topic, and it's one of those things where if you're 3D printing and you're not thinking about plastic engineering, then you're missing out on some of
massively
the benefits of it, and also like you need to kind of infuse this into your thinking as you're starting to design products for people, and it'll help inform what material to make it out of, what it will and won't withstand. Right, we're going to see some. I think as 3D printing becomes more and more popular for hobbyists, we're going to see some pretty epic failures. I'm really curious to see where people put products in places they shouldn't be, what those failures would be. But yeah, I mean, I think just dig around a little bit and you can start. You don't need to know chemistry to know something about melting, right? But realistically, if you're in this stuff all the time, you actually are an amateur chemist. You're already playing around.
You do learn a lot of terminology
with material science, right? And so you're already doing a lot of these things. So anywho, I think it's a really good discussion.
Yeah, I think it's rad. I think we should show off some Discord stuff.
Let's do it.
What do you think? Let's do it.
I would love to.
We actually got a bunch of people who are making very functional stuff this week, which is always our favorite stuff to talk about. But on the I made a thing, just fantastic stuff. Really quick, Edward, Mr. Charlwood, he is our co-author on our new Tinkercad book that is coming out in a couple, or good God, 10 days. That is going to be released. Tinkercad workbook on International Design Day. Yeah, we planned it. And he put this, he's actually going to be on the show next week, which is going to be really, really fun. We get to talk to the man. He's going to tell you all about Tinkercad and all about education and kind of where they intersect. But he was bringing up a really cool thing that Fusion posted yesterday. It's a thing called Project Salvador, and it's a built-in plugin for Fusion. And it's all about how you can bring in some of the AI tools finally natively into Fusion. So you don't need to do it outside and then bring it in. It's kind of all built in. So you can do a certain amount of inspiration where it's text to image, which we've seen. But what's really nice is you can also do text to image and then insert it as a canvas for background. The example that they use in the video, I've just designed a wooden chair. I want to put it into a medieval living room background, for example. And you just pop it in there. So it's really quick just to throw it in. But one of the things that I saw that's significantly more interesting is that you can actually design something, take a picture of it, and feed it through it. And it will actually use that as a template or as a source of information to then make an AI image. So it looks even cooler, even better, even more of a product design that's already kind of built into it, which is way, way, way cool. And it's got a bunch of other really fantastic stuff. It was posted on the Autodesk Fusion YouTube page. It's like a 4-minute video. Highly recommend you watch it. I haven't played around with it yet. I will absolutely be. But this looks like a ton of fun to do.
And I think that's one of those obvious use cases. I've been playing around with AI for a while now and trying to figure out where are the use cases inside of CAD. And I get a little bit triggered when people are like, oh, you can just automatically design objects. It's like, no, I actually think the use cases are probably more on the edge than in the middle right now. But you do have the ability to quickly generate renderings and drawings and things that were actually taking quite a bit of time in the past. One other thing I want to say really quickly about the launch. So we're going to be launching that new Tinkercad book. But Jake, I think it's a little bit broader than that. Actually, what we're doing is we're launching officially our publishing company, right?
That is true. Yeah.
So we have decided that in publishing this first book with Ed on Tinkercad, we're obviously very passionate about sharing technical information, and that we think books need to be better. They need to be like more visually appealing, more intuitive to follow through, and that like, there's this. I don't know if we've gotten complacent in book publishing in general, but you and I have talked quite a bit about this, and we think that we can curate and publish higher quality books in the industry. So we're not just launching Ed's book, but we're officially launching the CADclass Publishing Company. So
yeah, absolutely.
Just wanted to shout that out. And I have one ask, and we'll ask again next week as well. I have an ask that those of you who come by and support us, the book is going to be, for students, is going to be $12.99. For teachers, it's going to be $39.99. And we would very much appreciate a purchase and a review of that book if you all are so willing and have gotten value out of this over time. Jake and I know quite well with the first Fusion book, one of the big pushes that we made was we needed to get reviews quickly, or else you kind of go on Amazon. It's like if your book has 2 reviews, nobody's going to get there. So we had to go around and basically beg and pester to get initial traction. Fortunately, other people have decided our book is good, and it goes on from there. So anyways, all that is to say that we're super excited to launch CADclass, the publishing company, and if any of you are thinking about books and you think you've got a good topic, or you know somebody who is, be in touch. All right, Jake. Enough about us.
That was enough. All right.
That was the ad.
Let's show off some more people. So I posted this video that I watched with Thomas Sandladerer. If you don't know who Thomas Sandladerer, check him out. He's one of the best bits of information on YouTube about 3D printing. He is fantastic. Posted this really fantastic video about different beds that you can have. There's new stuff called PEY, which is how you can get really phenomenal, really kind of psychedelic effects on your first layer. But I will let you watch that video. Tons of really good information. But as far as people actually making stuff, which is what we're here for, Derry posted this. I didn't like how the stock door trim was designed. They always break, which is why both of mine were missing. This is a prototype. That's why it's green. Kind of like the green. I don't like it too much.
Yeah, I really. And again, this is right in line with this functional print. Make stuff that I go on this tangent every week. But I was meeting with our innovation cohort here in Sacramento. And I was talking about final project. Hey, let's make something. And when I said the word final project, I realized I had already sort of made a mistake, and I had gotten people to think too big. So I have a little bit of a bone to pick with people in the innovation industry who think too big. And I don't mean to say that there aren't room for the big ideas. Clearly there are. But when it comes to innovation, I would actually encourage people to think smaller. What is it in your own life, in your own house, in your own spaces that you can actually solve right now? So I had to kind of backpedal and be like, no. What I really meant was a final project to solve a real problem in your life. And somebody's like, like one of the engineering students at UC Davis was like, I bought this projector and the stand for it doesn't actually move the way I want it to move. And so you have to like stack books under it. So I want to design something to put. I'm like, perfect. That's perfect. Because that solves a real problem that is super annoying. So anyways, I would encourage all the people in this chat, just like this project right here, to continue thinking small when it comes to innovation. And don't worry, as you innovate, what happens is people around you go, oh, wow, could you do this for me? Oh, maybe we could work together. Oh, maybe we have this bigger idea, right? And so you kind of build this foundation of solving problems that other people gravitate towards, that then allows you to think larger than the individual.
Yeah.
So anyways, I digress. Awesome
so
work.
Fantastic.
Awesome.
But what Derry posted afterwards with Tom Sadler, the carbon fiber effect on there, that's not actually printed as a top layer or as a pattern. This is actually from the build plate material that you impress the plastic into. Then as soon as you peel it off, it actually has this effect on there. Super duper cool. Love that.
Has anybody ever had success, by the way, with the carbon fiber PLA filament? Because I certainly have not. I have ruined many a nozzle.
So as far as I know, there's there's really 3 different types. There is the one that just looks like carbon fiber, but doesn't actually have anything in there. Obviously, doesn't make it any stronger. Then there's the chopped carbon fiber filament, where there's just whiskers of little bits of carbon fiber in there. It might make it a little bit stronger, but
doubtful. I honestly think it probably just leads to spaces in your PLA. I would doubt it. Maybe it does. I don't know. I haven't tested it.
Insignificant for what you imagine you would get out of a carbon fiber material.
Yeah,
that's the idea. Then there is solid strand, where there's actually a full piece of carbon fiber thread that goes through the entire filament. I imagine it is stronger, but it's only strong along the layer lines. As soon as you want to separate those layers, there's no carbon fiber that's actually going into layers. So it's technically stronger in the direction that 3D prints are already really strong with, and it makes no difference in the direction that 3D prints are weak. So technically stronger with a very heavy caveat. Is carbon fiber 3D printing still rad? Yeah.
Well,
is it massively different?
Yeah, and maybe not on your home printer. And this, I think, is another thing that I'm going to yell into the universe about. And that is, you don't have to stick with just your home tools. I encourage you to use somebody else's 3D printer, aka Xometry or SendCutSend or any of the other outsourcing companies that have fancy printers with really amazing materials, so that when you're at the stage where you're like, I've got a prototype, it's not quite to production level, or maybe I want to see if I can get 3D printing to the production level, you could print all kinds of exotic materials on somebody else's machine. So don't stop at just your own machines, right? Yeah. You've got access to over $1 trillion worth of machines in the world. But you don't think about it like that. Now that you know how to design and you know how to make things, you can actually effectively communicate your ideas to those who have those machines. So encourage you all to, if you haven't done it already, to think about printing something on some fancy printer with some fancy material of somebody else's. And that includes, by the way, metal. A lot of companies you can get these really fun metal 3D prints.
And sometimes they do deals.
Sometimes they do.
Sometimes. All right. And then Mr. Mitnick posted this little purge bucket for an existing brush holder. So this is a project that I've actually had on my mind for a long time. The idea is anytime you are printing, before it starts on your print, it usually has a purge line. For enders, it's that long strip on the left-hand side that just kind of gets rid of any bits of material and any bits of filament that's sticking to the nozzle. It gets rid of the majority of it. For Prusa, it's that little blob in the front left corner. But every once in a while, you will have like a big, ugly blot of material on the nozzle. It's just kind of stuck there, and it usually gets embedded into your print, and it looks kind of ugly. So one of the things you can do is put in a little bit of custom code into your starting G-code, and if you mount a little brass scrubber upside down, you can actually make the nozzle brush itself over the brass brush. Because it's not a steel brush, it doesn't actually wear away the nozzle, cleans it off, and then it starts it, and obviously leaves a little bit of plastic. So I think this is what Mr. Mitnick is actually posting. It's got some magnets on it, so you can actually remove it and clean it.
PC Van Vliet here in the chat, by the way.
Oh yes,
shout out! One of our mods are still killing it. Thank you guys.
Yeah, thank you guys as always.
That's fun. I like the little. I like the little like infinite loop on this one too.
It's not bad.
It's nice. No, it's nice. Nice work.
And then coming off of, I'm not sure if I've seen.
I didn't see that one. I missed it.
Brian Glending. Making a little holder for some CNC parts.
Oh,
that's
cool.
Pretty rad.
That is
this stuff so
super
much.
Rad. And look at that. It looks like
it
slots into the extrusion. Whatever. Is that aluminum? I don't even know. That's some funky.
That's aluminum extrusion.
Just cut. Yeah, it slots right in there. That's super cool.
So these are some T-track clamps. No, those are dog hole clamps, actually. Excuse me. I'm not quite. I think these are also some dog holes, dogs inserts, I suppose. That go into it. That's pretty rad.
Really rad. Really rad.
I dig
Didn't
that
even
so
see that
much.
one. I don't know how I missed that. Oh, and then we've got some. What's going on up here? We have more stuff. Oh,
Yeah.
that's key to like.
From Keyed Alike. Oh, this is fantastic. They're showing off
Yes,
more of
yes.
their
He brought
project.
that actually in person. So if he's still here, if you're still
Oh,
here,
that'd be
Keith,
fantastic.
he brought that. He's a part of the SAC innovation cohort. He's a lock picker, and he's designed this mechanism right here. I'm super impressed. This is really cool.
That's so awesome.
Look at that.
Josh, do you know
cool.
about the 3D printing keys thing that you can do?
No, but that's interesting.
So
Tell
one
me
of the things
about
you
it.
can do, which obviously just do this as an experiment.
Yeah.
I can't even see you.
As you can take
One of the
a
things
photo of your key.
You can take a photo of your key. You can pull it into Fusion. You can scale it to be the right size. You can trace it and then 3D print it. And because it's printing flat, it actually does work. And it's strong enough to where it doesn't snap off inside.
I was gonna say who has snapped it off inside and now has a really bad time.
That sucks. Obviously, don't copy someone else's keys. That sucks. You can test out. I don't think I want to do it on my
I mean, look, you
door,
could
but
already like people that want to
way.
do it wouldn't do it that way, right? They just take the key
Yeah.
to one of those key creation places, and they right.
Yeah.
So you can already do.
But
If you really wanted to be nefarious with it, you could.
But super rad on its own. That's such a cool thing. I'd love to see that all that stuff.
Super,
sorry,
super
go ahead.
rad.
I think we had a couple more
Oh,
people.
and then Brian has his actual CAD file for.
Oh, sweet.
So if you scroll up a little bit further, you'll see the CAD. There it is. That's the CAD file for those clamps.
Oh, fantastic.
So huge shout out, by the way. I love seeing both the CAD file and the completed part with the stuff in it. Like really nicely done. I don't know if you ever watched these, Brandon, but super cool. And he's got another one up above where he had modeled the. Yeah, there you go. He had modeled. There you go. He had modeled the extrusion, and then he just built that around that extrusion.
That's pretty sweet. And he actually had a really, really clever design for this. Kind of a built into the CAD file support, where it's really thin and they could just snap it off later.
Oh,
that's pretty rad.
Interesting.
I do like that. That's not too shabby.
No.
I can see that being. Well, I guess if it's just something for a shop, I guess it doesn't matter if the underside is kind of bristled up a little bit. I guess that doesn't matter at all. That would be, if that works as well as I think it does, that would be a fantastic savings of material and time. That'd be pretty sweet. I'm very interested about that, Brian. That's not too shabby.
Cool.
And then I think that leaves
that's
up to
all the way back
week.
to it. Yeah. And then did anybody? I don't know if we got any chat. Oh, we did have ZDP. He joins these quite a bit. He's our let's call him our resident Tinkercad artist. I think is the best way to put it.
That's about right.
He's our resident Tinkercad artist, and he's trying to go through a lot of the Fusion book and see if he can do it in Tinkercad. Which, by the way, I love it as a design challenge. And he's just like really obsessed with designing things. So look at this Coke bottle. This is pretty impressive in Tinkercad. For those of you who haven't played around with Tinkercad, this is not easy.
This is not easy in slightest. That's very impressive.
Yeah. So
I love that. That's rad. And then we did actually have some really good. I actually did wanting to show off someone. I wanted to show off Moses.
Yeah, Moses is making a lot of progress.
Finally got the hang of rendering. This chapter was my best yet. Now I get to see why my work in realistic environments. We hear this every single time. As soon as people get into the program, they flick through the book and they go, I don't think I'll ever use rendering. And what we hear every single time is, I'll never use it ever, ever, ever. I don't need to learn it whatsoever. And then very quickly, when people just try out the rendering environment and they realize just how easy it is to make something that's just kind of a basic model look photorealistic and look fantastic, and with a little bit of camera know-how or photography know-how, you can actually make something very, very realistic. I don't think we showed off Connie's before this, which looks phenomenal.
Connie and Moses, I like it because they were kind of jamming through the program at about the same pace and doing most of the challenges together. Like, it just, how could you have predicted when we wrote this that like two random people who've probably never met, probably will never meet, are working through this together? And I feels a lot like they're encouraging each other through it as well. I don't know if you get that sensation, but I certainly do.
I certainly do. Yeah.
Yeah.
I think it's fantastic. And then I think we had a couple posts in the general discussion.
We did. Yeah.
Yeah. So what method would you guys use to join these pieces together like a kit card, thin tubes that come to a point where the contact is made. So this, okay. So they're talking about, oh gosh, what's the name of it? Is it the flash? I think it's the flashing. No, it's not flashing. Oh my gosh, I'm completely forgetting. I'm such a bad engineer.
It's like the channels that lead into the mold.
Yeah. So this is essentially copying what you'd get in plastic injection molding, where you don't do individual parts. It's actually an entire frame. So you only need to inject in one bit of plastic all the way through. And then all of these are just held together and they can be clipped off in the factory. Or if you guys are as old as me, you remember Airfix models where you actually came on a frame, then you have to snip it off.
If you guys are as old as me, you might be the youngest one in this entire. That's hilarious.
Fine. I remember doing these as a kid. I used to love doing Airfix models. I did it with my dad.
If you're a dinosaur they like I am, that's fantastic.
Yeah. That was just me showing off. Hey, I'm young and I know an Airfix.
Look at that.
Look at me. I've had, dude. Can I just say, as a person of a ever so slightly younger generation, the amount of people that we used to work with who, about the same age as my dad, and I'd just be chatting, and they would be shocked that I had a vinyl record, that I know what an LP is, that I know what a cassette is, and I'm like, really? Are you surprised that I don't think it's that insane. They're like, oh, you know who Adam Ant is? I'm like, yeah. It's not. I don't know. It always felt a little silly just how shocked they were.
PC Van Vliet says Jake has an old soul. I would agree with that. Jake, you do have an old soul.
Yeah.
Not in a bad way, in a good way.
I don't know.
Wise beyond your years.
Yeah, thank you. We did have a discussion really quick. Rad 3D showing off this little hexagon pattern that I do really like. On a project, and it can be a little tricky, but he had on one of them, it was actually misaligned, but the entire thing is actually defined, which is a really strange thing. I have no idea why just one cell would be kind of funky. And now the other hexagons are out of whack. Yeah, that's really strange. Making a hexagon pattern is not. It looks like it would be an easy thing. It's actually not. My poster that I have on my desk, if you guys are a fan of The Shining, is a little bit of a Shining carpet pattern.
That's fun.
Shining is one of my favorite movies of all time.
It's a great movie.
And making that pattern, super duper tricky. Not easy at all. It's actually a really good challenge. That's actually probably a good idea. Try and make the Shining carpet hexagon pattern in one sketch and try and extrude it. It is way harder than you think. But making this hexagon pattern is also not tremendously easy. What I have seen people do is use the pattern tool, and it's actually not super duper obvious how you do it. So I actually thought it would be a bit of a good experiment to actually go through and make a hexagonal pattern.
So you're going to be on your own doing that, because I'm going to pop off the pod here in about a minute.
Oh,
but I know, dude. We were like, oh wow, we're gonna be on. So I have a meeting to go to just after this. You're welcome.
Oh gosh, it is much fun.
But I
won't. I'll actually leave that till next week. But I will wrap up something really quick. For you guys that can see this 3D printer in the back, this is the 3D printed 3D printer.
Does it have the plastic pieces on it?
It does. All of
Go get it. Go get it. Just bring it over. Just bring it over.
All of the electronics are not secured. They're little floppies. Just recognize that.
Yeah.
Oh, jeez. Oh, God. Most of the weight of this printer is the kilogram of plastic at the top. It's a little heavy. But you can see all of the frame is PLA. I don't know if you guys... It doesn't weigh that much, but because all the weight is up top at the spool, it does make it really bloody top heavy. I'll try and show off a little bit more. Plastic bolts on top, dovetail joints holding everything together. You can see down there at the bottom.
And Jake, you're going to be filming the video for making this just after.
Yes, I'll be filming it today.
Little teaser.
Hopefully. Oh gosh, focus on me. I'm more important. Hopefully, the video will be posted on Friday. I'm really going to try and push to put it out. But I don't know if you can see, this is a flimsy body. This is a really flimsy frame, obviously. And at the end of the video, or at the end of each series, I'm going to be printing a Benchy just to finish off this feed, just to see just how bad this gets. The entire frame is plastic. The entire frame weighs less than a pound. That's all of the metal framework. And look at how bloody good this Benchy looks. That is not too shabby at all. There's a little bit of ringing in it, because of course there is. But look at that.
It's crazy.
That's not too bad.
That is crazy.
That's not bad at all.
Yeah.
So,
amazing.
Out of the way. That is coming very, very soon. Thank you for your patience. And we will see you guys next week.
That's the pod. This has been the CADclass podcast. Again, I'm Josh.
I'm Jake.
And we will see you all next week. Cheers.
See you guys.